The first one starts with, it's actually titled Quadratics Revisited. So there you go as far as what we're going to be discussing and looking at, okay? So the first things first is the characteristics of the quadratics. So do you remember like the different types of equation forms that they have? The standard, the...
Yes.
I remember standard.
I remember the word.
Okay, okay.
I don't know what that means.
All right, here we go. Let me get my colors going here. Sorry, I like colors. All right, so standard form is your y equals ax squared plus bx plus c. Okay, I think that this is usually the easiest one to recognize, right? So this one is easy to recognize as far as like visual purposes, okay? Other forms might be easier to graph, right? Do you remember that, does that shape of the quadratic look familiar to you? I'm left-handed, so you're gonna have to holler at me if I'm in the way, okay? So remember that's like a parabola, right? Okay. Vertex form. This is when you have your H and your K, which is gonna be your vertex. All right, this is the one that is easier as far as to graph. The H and K is going to play the role as the vertex. So that's usually your one that is easy to graph for you. Okay. And of course, there's nice little, that should already be on your paper though, as far as the different components of it. Okay. Holler at me if I'm going too fast. Okay. All right. Intercept form. This is the one that's easiest as far as to solve. This one looks like this. We'll work with this a lot as far as when we're solving. So this one is easy to solve. So you got three different types of forms as far as the equations go, and all three are different as far as whatever purpose that you're needing, whether it's, as far as knowing, okay, is that form, is that a quadratic? Well, the standard is definitely easier to recognize with that. Then you got your vertex and your intercept. Do any of those characteristics of the quadratic, do those look familiar to you? Like, do you remember like knowing what they are? I don't know when you would, I guess you would see that in what, Algebra 1? Since this is Algebra 2, because geometry was last, right? That's what you had last?
Yeah, I had stubs.
Okay. Yeah.
The only thing I remember from like math is like the y equals mx plus b. What is that?
That's slope intercept form. That's more 8th grade linear functions is what that is. That was my jam. That's what I always taught.
That was the easiest.
Yeah. Pythag, yeah. Yeah. All right. So with this vertex, notice that this graph, oh, that's really bad. Notice that this concave, right? It's concave up, right? Or you can also flip it and it'd be concave down. So with this vertex, would you agree that this is like the lowest point, right, that it possibly has? So this is what we would consider that the vertex can either be a maximum point, or a minimum point. So a max or min. And in this case, for this particular one, we would agree that it is a minimum point, right? And then, so this would be like your minimum point. That would be where your vertex is your maximum point, okay? Where it's concave down. And I think the x-intercepts, those are kind of self-explanatory. You got some y-intercepts. What could you tell me about that line of symmetry? Yeah. Yeah. Could you tell me that, how would I be able to identify it? I heard some middle stuff. I think the vertex kind of helps me a little bit, right? Because then it would kind of split it in half, right? You can see that reflection piece to it. But notice that it is also it's a line, right? Kind of have to know how to write that because it's a line. Now, which axis is that line cutting through? The X or the Y? The X. So that will always tell you where, first of all, you are going to be intercepting, and then what your equation is going to be. This one is cutting through where it's a 1, right? So this line, if we had to identify it, is x equals 1, okay? Which is also the, for the vertex, is also the x coordinate. So notice that this vertex is a point, and this vertex here, for this particular example, would be 1, -2. So those kind of go hand in hand. The line of symmetry or the axis of symmetry and the vertex x coordinate. How's that? Notice that the x-intercepts. Which coordinate is 0 on the x-intercepts? Are the x's 0 or are the y 0? Y's are 0, okay? That's going to matter when we get to some solving stuff, okay? All right, very good. How's that so far? Now you notice that this is all we're doing. We're just going to be looking and identifying these particular things. Domain and range is going to be the next thing we're going to add to here. But all right, let me scooch this up for you. On the x-intercept? Yeah, your y's are 0 on the x-intercepts.
Oh, never mind. Yeah.
So when we get to solving and all that jazz, that's gonna, that is why we're gonna set it equal to 0.
Yeah,
Getting into that. Yeah. Okay. All right. So solutions to the quadratic equation. This is getting into what we were just talking about. So the solutions. I wish I had a way like to type this up and it not save, but it's gonna save. Solutions are where the graph crosses the x-axis, which is what we were just talking about when I was talking about the x-intercepts. Okay? So those are also called, so another name, if I said solutions, I could also say, okay, well, what are the zeros, the roots, and then the one we just talked about was the x-intercepts. Okay? So a lot of different ways that we can say the exact same thing of what we're trying to find. I just posed it to you as the x-intercepts, and I asked you, okay, well, what would the y-coordinates be? Well, those would be 0, but then we have a x-coordinate value for those. So zeros, roots, x-intercepts, all the same thing when I'm looking at a quadratic. Where that function crosses the x-axis at. That's what we're going to be finding. I think on a graph, visually, that would be easy to find, right? Visually, that's easy. But of course, we're going to have to do that algebraically. All right, here we go. So with a quadratic, you're going to have different numbers of solutions. So for the one with 2 solutions, this would be where like kind of the example that we had up there. Notice that we have 2 solutions. They're on the x-axis. We can see them. We know what they are. Okay? So both of the sides of the quadratic, if that makes sense, is going through the x-axis. It's kind of important to know. Okay? So I could definitely figure out those coordinates for those ordered pairs. All right? Here's another thing. Disclaimer here. There is always 2 solutions. Okay? Always two solutions. These two solutions are what we would call real solutions. Okay. All right, this one would look like, am I going too fast or doing a slow up? Don't blink, you'll miss something. Don't blink. Huh?
You said slow.
Did I say slower?
You said slow up.
Do I need to slow up? Did I say do I need to slow up?
Yeah. You
Yeah,
said
that
up.
makes sense.
I don't think it matters. I'll be honest.
That makes sense. Some people say that.
It is slow.
Anyway.
I can grow rainbows here, don't worry.
Okay, so this one would be, notice it does say one solution, but what that's talking about, remember what solution says, is that where the quadratic is crossing the x-intercept. Notice when the vertex, right, is sitting on the x-axis, it's only touching it what? One time. So notice that's why it says one solution. However, remember there's always two. So this is the type where whatever this is, whatever that vertex is, it's going to be repeated. So like if it was at, I don't know, -1, 0, well I would put -1, 0 twice because it would be for both of those solutions. So it's repeated. So make a little note as far as when your vertex is on the x-axis itself, that is where the solution is repeated. It's listed twice, okay? All right. This one, it says two complex solutions. Notice that we've had the graph where the quadratic has, you can see both of them going through the x-axis. You see here where just the vertex is touching the x-axis. So this one would be where the quadratic is nowhere around it, okay? Here you have your vertex. Okay, so this would be the where you have no real solutions. It's called complex solutions. This is where it does not touch the x-axis. So visually, I think those are easy to see, but then algebraically, we're going to have to know how to understand them. Okay. How you doing? Questions? Okay. All right. Take a look at that equation down below. What type of form do you think that equation would be to the three forms that we have listed up top? Standard form? Yep. So I would definitely say that this would be our standard form. Okay. Now, what type of a format would our vertex need to be given in? It's what? It's okay, yep, coordinates, right? An ordered pair, right? We have x coordinate and y coordinate. And on a graph, I can visualize it and see, oh, it's right here, right? So what is that? -1, -4, okay? So I know that it's always going to be in an ordered pair format. Now, they have AOS. It's your axis of symmetry, your line of symmetry. That's what that is representing. It's the same thing as what they have up in the picture. In other words, it's that reflection piece. So where are we going to cut that quadratic in half? -1. So how do we write that? It's a line, right? So it's x equals -1. So make a little side note that this is a line, right? So that's a line. So it's always, if it's going to be, for splitting it, if it's going to be concave up or concave down, it's going to be x equals whatever that number is. So in this case, it's going to be x equals -1. And I'm also really bad about saying one thing and then I'll write something totally opposite because I'm not thinking about it. I'm thinking about something 5 steps ahead. So keep me straight. Keep me straight, okay? So know that that's your axis of symmetry or line of symmetry. Same thing. Know that's an equation. Yeah, is it a max or min? It's a min, right? Because it's concave up, right? So that's your lowest point. That's your minimum point. Your vertex is going to be your minimum point there. So this is definitely your min. Very good. Notice the next thing they ask. They ask you this in using the word roots. They could also say solutions. They could also say x-intercepts. They could also say roots. They could say zeros. What are we supposed to be looking for? Yeah, where the graph, right, the function crosses the x-axis. So I see here and here. So that looks like -3, 0 and +1, 0. So they could say zeros. They could say x-intercepts or solutions. Always know what they are asking for. Oh, what's that? Okay. What time do we get out of here? 9:10. Okay. 9:10. All right. All right. Domain. So think about this, that for this blue line to exist, there's ordered pairs that are generated as far as that particular equation goes that give us, when I connect all of those dots, right, all those ordered pairs, it gives me that function. So how many x's or what type of x's would exist to help generate the domain for that?
You're talking about how many x's are in the R?
Mm-hmm.
4.
No. Think about here. We go, like, all we can see, right? They gave us to -4 to +4, right? But notice, do those lines keep going?
Yep.
They keep going, right? And they're kind of going almost a slanted bit, part, right? So what type of x's are going to be? It's all of them, right? You can say it two ways. So notice that if I have it concave up or concave down for my parabola or quadratic, however you want to say it, that my domain, you can say it this way, which means all real numbers, or the infinity, right? -infinity to +infinity. You can say it either way.
I'm sorry, can you write that?
The R? Yeah. So it's kind of like two lines together, kind of like a parallel type of thing, and then you just write the R. So like your two lines, and then you write your R. Yeah. So like you do R.
Oh,
Like that.
I get it.
Yeah. It's just the two, yeah, it's just a fancy. All of the number sets are written kind of like with double lines type of thing. Yeah.
Okay, do an R. Draw an R.
And then just put the second one right beside it. Yeah, you just draw the R,
Okay.
and then you just put the second one right beside it. That's all you do.
I just like drawing infinities more.
Yeah, I like infinities too.
Yours are so really pretty.
All right. So it's going to take all of our x coordinates, right, to create that quadratic. But what about our y's? Now you got to think vertically, right, for the y-axis.
-4.
What's the lowest y coordinate? -4. And we're including that, right? So -4 all the way to +infinity. So think about this. If I'm including -4, my bracket is going to be not a parentheses, but it's going to be the bracket itself, right? Because I'm including -4. And then I'm going to positive infinity. Now notice positive infinity, we only have a parentheses.
Are the brackets just for real numbers?
Are they just? Wait, what did you say about?
I'm going to say it one more time. You ready?
Yeah.
Okay. So when I'm including that number, I'm using my little bracket. Okay?
Okay.
When it's infinity, or it's not including because it's an open circle or whatever the case may be, then I just have the parentheses. Okay? Notation is very important. You good there? Okay. So what I just said about the domain and range stuff is exactly what we're going to be writing right here. Okay. So for the domain, can you see this or do I need to scooch it up? Can you see this? Okay. So for the domain, it's going to be, remember, this is all possible inputs. Okay? And for quadratics, it's always what I just said, right? Real numbers, which is your capital R, fancy capital R, or you can say negative infinity to positive infinity. Okay? As you're copying that, I'm going to write down the range. Put a different color for you. So this is your all possible outputs. The graph is usually the easiest to tell, right? I am really bad about writing in print and cursive, so holler at me if you don't understand something. So domains will always be all of your x's when it's concave up, concave down, right? Max or min. And that's really important to know because when you get to pre-calc, if I have you in pre-calc, your parabolas will start turning sideways. So they'll open up left or open up right, and that's a whole nother story. So that changes that. So concave up, concave down for max and min, this applies. Now remember, range is all of your outputs. And then the graph, of course, is easiest to know. Okay. All right, ready to go to the next example? Was that a no, Caden? Well, good. I'll have some coffee while you're still copying.
Apple cider tastes good from the cafe? I know that's a weird question.
No, yes. And their hot chocolate's good too. Apple cider and hot chocolate, yeah. They used to, in Miss G's class, they used to get a lot of apple cider over there. Yeah. Huh? Yes, they do. All right. We ready?
Yes.
Okay. Okay, let me scooch this up. So what form is that equation in? Say it. Vertex form, that's right. Vertex form. You got 3 choices, right? Okay. Go through all of those different types of characteristics and see how far you can get for this particular example. Think about the format that they have to be given in and look at the one that we just did. One thing about math is you always use kind of similar examples to help guide you through the next one. James, you got it?
For the most part.
For the okay, what did you get for your vertex?
3.
Mm,
Or,
I know what you mean. Say it again. It's okay. Remember, it's a point.
X equals 1, Y equals 3.
That's right. So 1, 3, right? Remember, it's an ordered pair format. So 1, 3 is the format that we write that in. Okay? Very good, very good. All right, Brielle, what did you get for your axis of symmetry?
I got x equals 1.
Very good. And how do I know that that's what that is?
It's the x of the vertex.
Oh, yeah, exactly. Always with whatever splitting it down, right? Going right through the vertex part. Good job. All right, Caden, max or min? What you think? Minimum, and I know it's a minimum because it's what? Concave up. Very good. Very good. Okay. All right, Ansley. What type of solutions do we have?
You know, I just gotta say something. That was so funny because I was like, she's gonna call me for the one
It's
that I
okay.
don't know.
It's okay.
So I don't know.
Well, let's go back to our example, right, on the front page, and look at your types of solutions. So we can see the graph. So what do we notice about this graph and what this particular one is looking like?
There's no solutions.
Well, no real solutions, right? So they're going to be, as they call them, complex solutions, or imaginary numbers. We're going to get into that down the road, okay? But right now, we don't know what they are, but we know that they're going to be there's no real solutions. They're going to be imaginary. Is that example on the far right-hand side. Domain. Michaela, what do we always say for domain for these particular quadratics?
There's multiple x's.
Okay, give me better words. Give me some better mathematical words that we can use. We can say it two ways.
Multiple x-intercepts.
No? What are we talking about when we're saying domain? Like, what are we saying? What are we trying to identify?
The x
You-
point.
All of the x coordinates, right, that are making up that quadratic, okay? So how am I supposed to get all those x's together? Like, what kind of notation can I use? It's in your notes. And you know I will say that a lot. Get your notes. What do your notes say? As I will always say that. What's the whole point of writing notes if we're not going to use them, right? Found it?
You have to look at all the possible inputs.
The domain is all of the possible inputs, and so what do we write below that? What do we put?
Always real numbers.
Okay, they're always real numbers, so we use that capital R, that fancy R, right, to tell me that's the real numbers, or you can put it in the infinity notation, okay? So negative infinity to positive. So that's giving me all of those x coordinates, okay? All right. What would you say for the range, Javiera? Did I say that right?
Yeah, you did.
Yes.
I got 3 plus positive infinity.
Okay, am I including 3? Or am I not including 3?
Including
Okay, so what is that bracket supposed to look like?
like the little.
Yeah, not a parentheses, but the other one, right? Very good. And what am I going to have for the infinity? Parentheses. Good job. As you know, I'm zoning in on that notation, so make sure, what? Got it, good. Awesome. Okay? Are we good? Yeah? Okay. All right, I'm going to leave you alone. Try example 2. Or whatever your example is, the next one. Yeah. I like that I'm seeing you are labeling the characteristics on the graphs as well. That's good too. Make sure that you can identify them. That's good. Okay. Mark, are you ready? What kind of form do you think that equation is in?
Intercept.
Intercept form. Got it. Nice. Ethan, vertex, what you got?
X equals 4, y equals -4.
Okay, give me an ordered pair format. Because you're right on the coordinates. So how would we say that in
4, -4.
exactly how, yep, exactly what you got. Okay. Jackson. Now picking on all the boys. Jackson, what you got for, what are we on? Axis of symmetry.
Oh, X equals 4.
Good job. Joey, max or min? Min, good. And we also know that's a concave. Oh, good. All right. Caden, what you got for the roots? Are we able to identify those?
Yes.
Okay.
2, 0, and 6, 0.
Okay. Good job. 2, 0, and 6, 0. Kashan, what you got for domain? All real numbers. Good job. Isaac, what you got for range?
-4 to infinity.
Very good. How you doing? Good? All right. All right, let's dabble in the next one. Is that your example 3? Okay. All right, what form do you got? Standard, good. All right, what format is our vertex always going to be identified in? It's always going to be notated on what form? Ordered pair, right? Because the ordered pair, you can't, I mean, yeah, it's coordinates, but I guess depending on which class you're in, it's usually said differently. But yeah, because you have a y coordinate, x coordinate, so you always know it's x comma y. Good. All right. Axis of symmetry. What format is that going to be in? It's going to be a, yep, x equals whatever, right? Blah, blah, blah. Because it's a line. We're doing the equation of that line, right? That's why it's x equals. Okay, good job. And domain will always be what? For the concave up, concave down, will always be what? For all of, to notate all of our x, all real numbers, or you could do it as what? The infinity, right? Negative infinity to positive infinity. Good. And then, what's the easiest way to identify the range? Looking at the graph, right? That's the one that's easiest to look at. So you know it's going to be your minimum, right? Y coordinate. It could go, if it's concave down, right? It could go from negative infinity to whatever your max is going to be, okay? I think you guys got this, don't you?
Yeah.
This one? Well, this is a concave down. So those two sides are going where? To negative infinity, right? So I'm starting at negative infinity because those are my smallest y coordinates, right? And I'm going to, what is my maximum? Positive 4, right? And remember, are we including 4? Yes. So parentheses on the negative infinity, but then include that 4. So do the bracket on the 4.
So wait, the infinity goes first?
Negative infinity, because you got to think, where is it going? Right? So my smallest, because here's all my y's, right? So my smallest y is negative infinity. Oh, that's really bad. That's really bad. Okay? But then our max here is not going to get any greater than 4, so we have to include that 4. That's our max. So our min to our max, right? From our y, all of our y coordinates. I'm glad you asked that question. That's a good question. Does that make sense? Okay. Yeah, we haven't really had one like that. I'm glad that we got that.
Yeah, we didn't have a down.
Yeah. What do you think the form is on example 7? Let me find that one. So I'm here in the intercept form.
I feel like he's thrown this same question out.
I think it's vertex 2.
So it's both. Would you agree that it's vertex and it's also intercept form? Like it's kind of both,
Yeah.
right?
Yeah, because
Yeah. So if you look at your
You don't need the plus K.
yeah, the plus K, that's just because of 0, right? So yeah, it's actually both. Vertex and intercept form. Good job. Okay, so tomorrow, what do we have on the agenda? Oh, we're doing the solving. So we're going to be doing a couple different objectives, I guess, on solving with the quadratics by factoring. So that's getting into some algebra stuff.
Dropping out.
All right. You guys are great, by the way. I heard a lot of kids like it.